Electronics and Communication Engineering at GIMT-Guwahati, that is Vijayananda Chaudhary Institute of Management and Technology. Hello students, you have seen probably this kit, that is Optical Fiber Communication Kit, Optical Fiber Training Kit or OFT kit. This kit we will be conducting around 3-4 experiments in this kit, but today I will be conducting only 2 experiments. Mainly your numerical aperture with this device, and one more experiment we will be doing regarding the attenuation of the fiber which we will be using for this lab, that is plastic optical fiber, which is normally used, a very rugged type of optical fiber which is not that much delicate and also giving good response in this manual laboratory purpose. Because of the video limitation and all, I will be going very precise. I will not be repeating that much and will not go around bush. So let me start this one, and let me start with the introduction of this complete kit. This part is the transmitter part, which is going to modulate and it's going to transmit the optical fiber. These are the sources. That is, this is a visible source. This one is your 650 nanometer, which is in the visible range. This is your 850 nanometer, which is in the infrared range, and this is in the electrical domain. So these two are optical output and this is an electrical output, and this upper part is the receiver part. So this is going the transmission, and through optical fiber it will be going and reaching over here as a receiver. So this is the optical detector, that is photo detectors and all. So one of the detector is not connected, one detector is available, and this one will be taking this output to this input output IO. You can see IO1, IO2, IO3, IO1, any one of them will be connecting it, and then this is connected through this BNC cables. So from here we will be connecting to the CRO. Now in the first experiment we don't need all these things, we only need to see what is the light gathering capacity of this fiber, that is numerical aperture. So we will be using only this transmitter part, only this optical output part, not using all these things. Fine. So for numerical aperture output or analysis, we need to use only this visible part, because we have to analyze what is the output part. So we need to use only this visible 650 nanometer rather than this invisible one, that is infrared one. So I think you can see some light is coming out. So this is the output of your from this plastic optical fiber, POF. Now we will be putting this into a dark room. Actually a dark room is required. So there you can see this numerical. So we have made the room to be quite dark, and you can see the light is coming out from this optical fiber, and there is one reference. You can see it's 1.5, 1.5, 2. So wherever we will be keeping, it depends on its height from where this optical fiber is placed above the floor, and that way this circle is being formed. So we have to take one ruler and we have to see what is the width of this side and width of this side. So this will be one measurement and this will be one measurement in accordance with this height, and we will be calculating the numerical aperture only based on this one. So this one, the calculation is given in the manual that I will be providing you at the end of the video. So this height we have to measure this, and first we have to keep it to be 0.5 centimeter, then 1 centimeter, then 1.5 centimeter, and correspondingly we have to find out what is the breadth and height of this diameter. Fine. So with this we can find out the numerical aperture of this optical fiber. Remember, numerical aperture is very specific to this optical fiber, and this optical fiber is of 1 meter length, made of plastic optical fiber, very precise one, and the cost last around I have bought it around 8 years back, and the cost of 1 meter is 500 rupees.